All right. Dr. Sholders, it's a pleasure to have you on the podcast.
Thank you.
I think to start, I just want to hear your philosophy about teaching. You've done some research on teaching, and you're one of the best teachers, maybe the best I've ever had at university. So what's your philosophy? What goes through your mind?
I think that probably like the thing that I think about most in terms of my teaching is to connect with my students. So, I mean, there's lots of things that I'll do in a classroom, but I feel that if I can connect to my students in a meaningful way, they have a much better chance of learning the content, and I think they'll be much more engaged with the content. So, like overarching things that I do in a class, a lot of them are essentially done to connect with a student.
Yeah,
so,
I think that's definitely one of the things that I found to be the most fun about your class. You weren't just up there parroting information for an hour straight and then we leave and we're kind of brain dead. Like you opened it with a joke and you made it engaging, and I think that's so important with teaching. Of
course, yeah, I mean, for sure. And then there are other aspects of it that are kind of behind the scenes for me. So some of the research that you mentioned, I actually just published a paper like 2 days ago. It got accepted.
Congratulations.
But some of the I think that you took a pre and post test. Remember doing that in the class? Yeah. So that test actually was the culmination of a couple years of writing the test. So, and then we offered it as a pre and post test, and then track numbers, right? So, what do students know, first of all, when they come into the class, and then what kind of gains do they make during the class? And so the test was written in such a way that it was targeted at specific learning objectives.
Okay.
And so interestingly, and I mean, like if you look at the test as a whole, students learned, right? The statistically significant improvement across the board for all students, which is what you expect. But then the nice thing about that test is that each question was targeted per specific learning objectives.
Yeah.
And there were learning objectives, and we had over 850 students analyzed by the time we were done with it.
Dang,
so
that's a pretty good sample size.
So it's a big sample size, but there were some questions where students had no statistically significant improvement, which means that we really weren't effectively teaching students.
Yeah. So was the goal with this to just assess your own teaching in biochemistry?
Yeah.
Okay.
To assess it first of all, and then in the future, if we make teaching adjustments, right, what we would call interventions, then does that lead to improvement in students, right? So we can target those areas and we can say, okay, we're not doing a very good job in this. What can we do better? And then if we adjust, do our adjustments improve or hurt students, right?
Yeah.
So or something along those lines, because those types of adjustments are really hard to make. And so a lot of times as a professor, you're kind of stuck with, well, I'm just going to do it because I think that it will be better, but you have no way to
gauge whether or not it's going to be better.
Yeah, right. I mean, you go off of scores on tests and that kind of stuff, but we took that to another level and said, okay, well, what if we were to do this, right, this particular test, and then administer pre and post, and then analyze the results, and then use that like as a kind of an assay as a scientist, right? To say, okay, so now we have identified a problem. If we do this, then this should cause improvement, right? Or should lead to improvement. And now we have a way to test whether it does lead to improvement. Right?
Yeah.
So that was my thing. Like as a scientist, I want some way to test.
Yeah. So if you're teaching a class, I mean, you're a teacher, but you're also still a scientist. So you want to approach it in a way that improves over time. And this, I mean, it sounds like a perfect way to do it. I don't know. I may have had other professors do it, but I don't know how many here.
Well, there are lots there's lots of ways to do it. And so, educational research is lots of different methods of testing, whether students are getting or what's the word, or obtaining the learning objectives. That would be a good way to say it. And some of them, though, they're really difficult to do. Like I'm a scientist, so I was trained as a scientist, not as a educational researcher.
Yeah.
Right? So some of these tests are called concept learning inventories or learning inventories, or I guess concept inventories.
Okay.
but writing those is really difficult. And so like the literature on how to write those is, you have to spend a lot of time, and there's, it's a very difficult and arduous process.
Yeah.
So what myself and my colleagues wanted to do is find a way that just a normal instructor, professor could write something that didn't reach the bar of what we would call a concept inventory.
Yeah.
That takes really specialized training to do, but rather kind of lower that bar and say, okay, can we do this? And then can we at least have some way to assay, if you will, the improvements that we make?
Yeah. So it sounds like something that's not as like arduous, but something that's more accessible for like the average professor to do. I mean, all they have to do is make a test that assesses the learning goals and then just give it at the beginning and end of each semester and, run it through a statistical analysis and see how they do.
Exactly. Yeah. And so that's what the paper was that we presented. The paper was actually a methods paper.
Okay.
So this is how we did it. And we presented some of our results, but we weren't actually trying to communicate our results, and our interpretation of those results to the field. We were rather communicating our method.
Yeah.
So other instructors can take that method and do that. And we even published, how we statistically analyzed it. And then other instructors can do that. They don't have to publish that. They don't have to publish even the results from that, but at least they have some way to say, okay, this is where I need to target my instruction. This is how I'm going to do it. And then analyze, was that helpful?
Yeah.
So
yeah, because I was wondering, like, when I took that test, like, what was it for? But that makes a lot of sense, because I would imagine professors have a lot of trouble like doing exactly what you just said, where if they see students struggling in an area to improve it, but this just completely confines it to the scientific method and allows you to make adjustments semester on semester and iterate it over time.
Yeah. The trick with it is, in a class like what you took, I have 250 students. To really analyze what students are learning, the best way to analyze them is to do something like this.
Yeah.
Right? To sit down with them and have interviews with a student to find out what kind of misconceptions that might be present. Because the test that we presented was actually a multiple true-false question exam. And so some of the method that we presented is, how do we know that our students aren't misunderstanding the question and therefore are getting, some of it, because they're guessing, right?
Yeah.
So they could be guessing. So we said, okay, well, let's have it be true, false, and I don't know. Right? We want you to be honest with us about this. We're not going to count this against you. But some of the method that you didn't get to see was that we did it at first. We presented as a multiple true false question format, where the first semester we did it to like 15 students, and we interviewed students and we identified, okay, so some of these students are not even understanding the question.
Oh, yeah.
And so we had to rewrite the question, and then we did it again like that, okay, smaller cohort. And then we did it to a large cohort where we didn't interview students, but we gave them the ability to say why they answered the question. And then we had to rank their reasoning. Okay, so why they got it right or wrong, was it valid or invalid? Right. So sometimes there were students that would get a question right
for the wrong reason.
Yeah, for the wrong reason. They didn't have it for valid reasons, or vice versa, right? They got it wrong for what we would call invalid reasons, right? They understood they understood the concept, but the question misled them. So the process of how we wrote that exam was kind of the arduous process.
Yeah. So did it have more to do with the complexity of the questions and the content, or just like the actual wording and syntax?
Wording, syntax, was what we were trying to identify.
Okay.
So that our wording was not misleading students away from, or even to, the right answer. So that was what we're looking for. The complexity of the question, I mean, we tried to make it in such a way that you're not asking multiple things in one question.
Yeah.
Right? So, because that can be hard to analyze as well. If you have two statements in one question, and a student says this one's true but this one's false, how do I answer the question? You see what I'm saying? So some of it was complexity as well. But then we got to the place where where every single question we were confident that at least 85% of our students would understand it in any given semester.
Yeah.
And so then at that point in time, we then could present it and say, okay, this is a valid tool or what we call an instrument for analyzing learning gains over the course of a semester. So
that's super interesting. Yeah. I'm kind of glad to close that loop for myself. But yeah, I think it's just really cool that, you know, you're like switching. I mean, what made you decide to switch from like biochem research? Because that's what your, you know, PhD was into, more like educational, like improvement on how education is done at the university level.
That was probably more of a personal decision. Certainly in terms of what I wanted to do with my life and what I wanted to do with my career. So I didn't have a great interest in pursuing straight biochemical research as any, like maybe academic professor might do. So the process of writing grants, although I've written some grants before, and then, you know, and all the demands that are put on what would be considered a research tenured track professor were not of interest to me personally in my career. I had more of an interest in education and teaching. And that started all the way back as a freshman.
Like an undergraduate.
Oh, wow. Yeah. Where I said, you know, I was actually coaching a football team at that point in time, or helping coach a football team at that point in time. And I really enjoyed the interaction with students and the players. And so, and I'd always find myself, even in my classes, kind of helping other, you know, classmates and teaching and enjoying that. And then my focus just kind of narrowed from there. At one point I said, well, maybe I'll go to, because I was initially wanted to be a physical trainer.
Oh, like a PT?
Yeah. And I was like, nah, I don't want to do that. You know, and it's really athletic training is what I was interested in. I was an athlete at the time. And I was like, I don't want it. Actually, what I found out is that job, unless you're like, you know, working for the Rockies or something like that, you know, you're not going to get paid very well. The hours are going to be pretty bad for a family anyway. It would be still interesting, you know, but it wasn't what I wanted to pursue. But I was in biology and chemistry at that time, preparing to get into the athletic training program at my university. And I was really enjoying those subjects. I said, well, maybe I'll just, you know, go on and be a high school teacher. And then I could coach football or, you know, coach and do those things. Yeah. And then I got into that and I was like, I don't know, I don't know if I want to just teach just biology and just chemistry for the rest of my life at this level for high schoolers. And the teaching demands on a high school teacher are extraordinary. Yeah. I mean, those people are remarkable.
Well, they teach like 8 hours in a day. And I'm sure like as a college professor, you have a lot of work, but you're not lecturing for 8 hours a day.
I'm not lecturing for it. Yeah. I'm not in a classroom for 8 hours a day. So I have a great deal of respect for a high school teacher. Oh, yeah. So but that didn't interest me. So I thought, okay, well then I guess that would leave me with education at a collegiate level, which means I need to get a PhD. Yeah. Which means I need to do, of course, research. So, and actually I did a summer of research here at CSU. And that's, I think, probably the kind of my foot in the door here at CSU, because then I came here and got my PhD. Nice. And then was fortunate enough to be hired on as a faculty. I've been here ever since 2001, actually. So. Wow. Yeah.
It's a long time.
I know, right? It sounds like a long time now that I think about it.
Yeah. So. I mean, that's like as old as I am. So.
Yeah, exactly. Yeah. So
that's interesting though. Like I'm not sure how many professors go get their PhD and do research to teach. Yeah. I can't imagine that's a common thing, but I think it's good because I mean, that's going to end up being what a lot of their job is at the end of the day, is teaching. So.
For sure, yeah. I think it probably depends on where you are in terms of you know, what department. So there are, like at CSU and those types of departments. So maybe not Stanford and that kind of thing. It's not. Well, I guess I should say this. You find a greater inclination in those graduate students towards teaching and education and more basic research. Okay. Although some of them want to go on the private sector and do things like that. It just depends. But but it's definitely becoming more common for for graduate students, at least this is my anecdotal interaction with people, for graduate students to think maybe I'll go on and teach, because there are becoming at universities specific roles like mine where it's just straight teaching and maybe a small amount of research that you're doing.
Yeah.
Both at small and large universities. That's becoming more common.
Interesting.
I mean, it's always been there, like liberal arts colleges.
Yeah.
But larger universities are seeing the need for saying, these faculty members, their expertise is like scientific research. The demands put on them are so great that they
shouldn't be teaching.
Or they should be teaching less.
Yeah.
Right. So we'll try and reduce their teaching load, but then that means that someone has to pick that up. And then there has to be someone that's interested in doing that.
So it's kind of like they're starting to delegate more and make it so that people are more specialized.
Absolutely. And the way funding is, especially lately, I mean, especially in the last year, or in 6 months, that's becoming so much more competitive. And it becomes such a taxing effort on professors that they're required to get funding to get tenure and to get promotions and that kind of thing, that it makes sense that's going to be like their primary focus. Yeah. And therefore, if they're thrown in a classroom, which a lot of them are, that becomes a secondary thing for them.
Yeah. And then I would imagine the teaching quality just isn't as high as it could be if you had someone who was their main gig was teaching. Yeah. And they're not in the classroom thinking about whether or not their grant is going to get approved or what's going on in the lab at the moment or whatever else that they care probably more about.
And rightfully so, that they would care more about that, because when it comes to it, when you start to look at the obtaining of tenure and promotions for a person in that position, if you don't have funding and you haven't published, you won't get it, no matter how good of a teacher you've been. Yeah. Right. So, and that's the reality of the situation, right? And not that the university doesn't look at their teaching quality, but let's just put it this way. If their teaching quality is less, but they have great funding and lots of publications, they're going to get tenure, right? I mean, that's the reality of the situation. And that's what they've been trained to do. Right. I mean, their entire, starting from as an undergraduate all the way through graduate school, and then they go into postdocs. Some of them have 2 or 3 postdocs. That's what they've been trained to do, is research and write grants and publish papers. Right. Yeah. So with very little teaching. Set. Yeah. And so it's an expectation that they would continue to do that. So then a person like myself that says, I don't want to do that, it was starting to see, universities are starting to see the value in that. So do you think, generally speaking, that's going to change universities for the better, or do you think it'll introduce more administrative bloat, or how do you think that'll play out? Yes. Large scale. Yes. Okay. Great. Administrative bloat, I think, is always going to be a problem, with any institution, academic or non-academic. Yeah. I think that it will improve I think that it has the chance of improving undergraduate instruction. It should improve undergraduate instruction, which will be then ultimately better for the university. So I think that a larger number of students will be reached. Yeah. Rather than just your really top performing students.
Yeah. So. That makes sense. I mean, you'll still probably be paying out the butt for it, but it'll maybe be a little bit more worth your money.
Yeah. I don't see the price of education going down
anytime soon. Yeah.
So, it's hard to say what the future of education is at a university.
Yeah. If you could wave a magic wand and I don't know, reshape how universities are structured, what would you do?
I would, without a ton of thought, so this is just an opinion, certainly just an opinion, not based on research or anything like that. If I were to wave a magic wand, I would like to see a university become more specialized for students, meaning that it becomes more focused toward career and specific career objectives for students.
Yeah.
So more of along the lines of a trade school idea and model, right? So there are, of course, plenty of institutions, academic institutions, that train someone to be a mechanic or to be, an electrician, or to be, and they're very focused, and the students, that's all they focus on is that.
Yeah.
Okay.
Yeah.
I think that there are a lot more disciplines at a university that
could benefit from that.
Yeah, it could benefit from that model. And then while tuition will be high for students, it could be potentially a shorter period of time.
Yeah.
Right.
Because you're not spending as much time learning like fluff classes.
Exactly.
Pretty much.
Right.
I mean, just thinking about it in my instance, how much have I learned in my undergrad that I'm realistically never going to use as a doctor? Probably most of it would be my guess.
Yeah.
I think it would be I totally agree. And even at like high school level, it would be a lot more useful to actually start giving you the skills up front, because at the moment, the current model almost seems like the degree is just proof of that you can dedicate yourself and that you can work hard. And it's just a piece of paper that says, I can work hard. And then the company hires you based on that. And then they do all the training on the back end. Whereas if you could start learning it on the front end, like you said, it could be shorter, probably more engaging. I mean, the classes that I enjoyed the most were the ones where I'm like, yeah, I'm going to use this one day.
Right.
And maybe a little bit cheaper if it's shorter as well.
If it's shorter, it would be cheaper as a whole. It would be cheaper, for the student, rather than 4.5 years.
Yeah.
2.5 years, 2 years, depending on what you do, right?
Yeah.
But yeah, and then more integrated, right? So like, for instance, you took General Chemistry 1, General Chemistry 2, Organic Chemistry 1, Organic Chemistry 2, Physics 1, Physics 2, right? And biology, and then in the biomedical sciences and biochemistry, and like, but those subjects, right, for you, because you want to go on into medical school, what if we had a more integrated view of how to do that, right? And there was specific departments that looked at, okay, let's do away with some of these prerequisites because we can cover what they need to know in these things, right? Can you get, again, this is waving a magic wand, but what in General Chemistry 1 and 2 does an individual that wants to go into medicine need?
Yeah.
What, and what do they need from physics? What do they need from these things? And then instead of just saying that
all of it.
Yeah, like this person in organic chemistry is actually going to be an organic chemist at a pharmaceutical company. So what they need to know is much different than what you as a doctor needs to know about organic chemistry, right? Yeah. So, like, again, waving a magic wand, because this is like idealized.
Yeah.
But it would benefit the student to separate you from those individuals, right? And go along those lines.
Yeah.
But then it'd be more individualized.
Which, kind of to your point earlier, would probably also tremendously help students.
But at the same time, make it much more expensive, because
more teachers, more classes, more classrooms.
Yeah. You're right. So, I mean, if you're going to individualize things, not only that, but a lot of students coming to the university have no idea what they want to do.
Yeah. What would you say to those students who
don't come to the university?
Yeah.
I mean, that, like I have a 17-year-old right now that he doesn't know what he wants to do, and it's like, well, you're not going to go to college then until we have like an understanding of what you kind of want to do at college, because of the amount that you have to pay. We need to get a job. We need to find, we need to discover those things. And my other two didn't go to the university, and one of them did one semester, and like, this is not for me. But he right now is getting his pilot's license, and and has an opportunity at some point in time. He's going to fire academy this summer. Wow. And he wants to do search and rescue, and ultimately wants to become a Black Hawk pilot, right? So and none of that can be
done at college.
Right. And he gets paid to do those things, right? He's getting paid through the military.
Well, I found those processes to be much better in terms of learning, because I have my EMT certification, and like I had to do a class for that, and it was a lot of learning, a lot of classroom time, but all of it, every part of it was useful, and it gives you a skill. It gives you the ability to go out into the workplace or workforce and start working.
Exactly.
Yeah. And like actually apply the knowledge that you spent so long learning.
Right. And so then, so to kind of break out of the mold of like 4-year university, quote unquote, university setting. What does that look like? I mean, the idea of the university, even the word university, means that we're trying to give a student a universal education. But that's that ship sailed long ago. Right?
Yeah.
So even with what we would consider our general electives, I don't know if our students are really at the end of it, have what would be considered a unified body of knowledge.
Yeah. Plus, like, it's not so anymore that the university it used to be the only place with that information. They had the library, they had the people who knew it, but now with the internet, you can go buy a history textbook, go buy a calc textbook if you want. It's like Goodwill Hunting. I learned all that you did for $3.50 in library fees,
Exactly. And then that's going to become even easier access with, AIs.
Yeah,
right?
AI.
Naturally. I mean, like Copilot, you just sit down and have a conversation with it, right? Yeah. I mean, like, I don't understand this, and not that that's. You still have to watch out for that, right? I mean, because AIs are going to get things wrong. They even put a disclaimer on it that they're going to get things wrong. And I, as an expert in a field, know how easily they get things wrong. As you start into a deeper portion of the conversation. But I mean, they're going to serve a role and they're going to serve a purpose. And certainly, a person that's motivated to learn something, maybe not become an expert in something, but if they're motivated to learn something, they're going to be able to find that information.
Yeah, and so AI is just going to reduce the friction on. I mean, my hope would be that AI just completely reduces the friction on that, and people learn more, as opposed to people just relying on AI to do stuff. But I mean, I use AI a decent bit, and ChatGPT has like the deep research feature, which is kind of great. You have it research X topic and it comes back with like an undergraduate research paper pretty much, and I can read through and be like, okay, I understand this topic like at a reasonably good level now, as opposed to it would still behoove you, I think, in some instances to do that research and check it, because it can be wrong. But for basic stuff, like, it can be really useful
for an introduction to things, right? I mean, it used to be Wikipedia,
but now it's going to be this, probably.
And now it's this, and that's what I've taught like senior thesis courses and senior seminar courses, and in those, it used to be that, okay, watch out for Wikipedia. You can get things wrong, but it's a good place to start, right? It should have references to papers, and it should give you just kind of a basic understanding of this particular field.
Yeah.
Right? And that's good. Well, Wikipedia, I think, will be replaced. I would hope that the way students would use it is that it will replace the Wikipedia, because it can be a lot more engaging and a lot more targeted. But it still should be viewed with, okay, some level of scrutiny. And like this, this last semester, I encouraged some of my senior thesis students to go ahead and start your research using an AI.
Yeah,
asking it for references, but understand that it's only going to quote from like abstracts, and it's going to get things wrong.
Yeah.
So you're going to have to read the papers that it's referencing, but it can at least give you an overview and start pulling things together for you. So,
yeah. And
I mean, I use it.
Yeah. It's really good, and I totally agree that it's going to be like a Wikipedia. Of course, you run into the issue of like someone has to do a research paper and then they just have it write it. But that's,
that's I mean, we can't take that away.
Yeah,
people are going to cheat no matter what you do.
Yeah, and that's only really going to hurt them at the end of the day, because like they're really not learning anything now if they do that. But yeah, it is a place to start. I agree that it's really, really great for that. But you still have to go into the papers and have, go in there with a critical mind and look at it intelligently and know what it's saying as well.
Yeah, and I think that's going to what's going to be the result of that is that universities, in particular at like a graduate level, are going to start relying a lot more and trusting a lot more oral examinations.
Yeah, my hope is that we just start to go like hyper in person in the coming years, because increasingly it's going to be the case that a lot of the things you see on the internet and on your screens are just not going to be real. They're just going to all be created by AI. So people are going to start to value the in-person stuff more because they're going to be like, okay, I know this is real. I know this is human. They're right in front of me, talking to me.
Exactly.
And even if they studied with AI or prepped their speech with AI or whatever, they still are incumbent to understand the knowledge, hopefully, and deliver it at the very least.
Yeah, I mean, there's, I think, a fairly significant conversation going on amongst faculty, in particular in graduate programs, about what are our requirements for students for entrance into like PhD candidacy and these kinds of things. And it used to be, and still will be, the writing of a paper. But how do you tell students? Yeah, I mean, do you say don't use AI, right? And so there's a debate amongst faculty members. Well, like, are we then taking away a tool from them that honestly they're going to use? I mean, there's this whole debate about it, and ultimately, I think what's going to happen is that there is going to be a discouragement of using AI to generate a paper for you, rightfully so.
Yeah.
But there is virtually impossible at this point in time to police that, right? So then, like you said, hyper-personalization, right? An oral exam, if a person uses completely AI to write a paper, then they're examined on that paper and the things that led into that paper,
on it and stuff,
and they're grilled on it in a face-to-face environment. You can't fake that.
No.
I mean, you can't AI that. You have to know that at that point in time. So I think that will become one of the ways that a university is going to have to go.
Yeah.
Which takes time to do that.
No, it's a constant evolution, and we're just going to have to probably adjust to it as it goes. And it keeps evolving, and we'll just have to keep matching it and hopefully keep up. Yeah. And maybe use it to evolve, have it give us some ideas on how to combat it, almost, maybe something in that regard. Like, hey, ChatGPT, how can I make it so that you aren't used as much? How should I interview graduate students to make sure that they're actually knowing it and not just using you to learn everything? Or
how do we detect that you wrote something?
Exactly. Yeah.
Like, that kind of thing. I mean, these AI, I mean, the AI detectors right now are worthless.
Really?
Yeah.
Okay.
I mean, at one point in time, Canvas and all these course learning management systems have plagiarism detectors and everything, which were really actually quite effective until the advent of generative AI, and now they're worthless. Because they can't. I mean, they say that they can, like they'll give you some percentage of like, this is likely AI, but it's totally untrustworthy. Totally untrustworthy. It's been tested, and even the companies that are generated are like, well, I wouldn't trust it.
The big thing is the hyphens. I don't know if you've noticed this, but ChatGPT will, like, if you have it write anything longer than a paragraph, it will almost without a doubt use like one of those hyphens instead of like a semicolon or something.
Oh, really?
It's been like a dead giveaway for me.
Okay.
Yeah. So you put that one in your back pocket, because I don't know a single person who's ever used one of those, like, in like an email,
Yeah. Right.
So they're pretty dead giveaways.
Really? So it's a height, like,
well, it's when you like put two hyphens and then it like makes the bigger one. What's that called? It has a name.
I don't know.
Yeah, but it's like you put the two hyphens
together and then
it like makes the bigger one.
Oh, okay.
Yeah. So yeah, it has a name, but I can't remember it off the top of my head.
So there's formatting.
Yeah, there's specific formatting, and then the eeriness of like, dang, this is like really, really well written, Really well written. Yeah.
And that's the hard thing, because there are some students and certainly professors that are really good writers.
Yeah.
I
mean, where do you think ChatGPT got it from?
Right.
Someone.
Yeah, it had to be trained. But I use it more for like grammatical checks and that kind of stuff. And then just like if I'm doing like just kind of starting like a research, like I have a question about this, like instead of like putting it out on the web, it's nice to have an AI there and ask this specific question. But there's times where the question I ask it is like, that's definitely not the right answer.
Oh yeah, especially with like higher level like biochem stuff, or even undergraduate level courses, like it's just not gonna be able to understand it.
But it will at some point.
At some point, yeah. I mean,
depends on how the models are trained.
Yeah, like 2 years into it now, and it's already making leaps and bounds every month, it seems.
Yeah, for sure.
Yeah. But then on the flip side, besides like the kind of unfortunate stuff, we have stuff like AlphaFold. I think we've talked about that before.
Yeah.
That's like really, really,
really fast,
really cool. Yeah. And that's only going to get better too.
Yeah.
Because it's kind of just like an LLM for proteins and how they fold.
Yeah, it's amazing.
Yeah,
it's truly amazing. So I think that the developers of that just received the Nobel Prize.
Yeah,
so
unsurprising.
So.
Yeah, that's like pretty groundbreaking.
Yeah, groundbreaking, and it's going to open up an entire field of research that was inaccessible at one point in time.
Yeah, like
protein design.
Protein design, exactly. Yeah. I mean, the medication design and everything. The issue, of course, is going to be taking that to synthesis, but
sure,
I'm sure
injecting proteins that are foreign to your body is,
dicey.
Is just asking for anaphylactic shock, right? I mean, so of some sort, the immune system detects something foreign. So there are definitely challenges from a translational standpoint in terms of medicine, but some of the potentials for other things I think are really remarkable, having proteins. Yeah. Designing proteins to do specific things.
Yeah. Like what have you seen in that regard?
I haven't seen, I'm like just letting my own mind like go on what you could do with some of those things, but I haven't delved into that area of research, like protein design at this point in time. So.
Yeah. Like where could you see it going?
Well, I think that you could see it in terms of all sorts of diagnostics, designing, proteins to bind things that proteins don't normally bind, and then giving a feedback to that. So detection of molecules and all sorts of in a particular mixture, designing a protein to bind that, and then have a feedback to diagnose something like that, or to be a diagnostic or something like that. I mean, that would just be one. Yeah,
almost like a amped up ELISA or something that's a lot easier to use almost.
Yeah, exactly. Stuff like that. So, and that's just, I'm sure there are much smarter, much more experienced people than me that have like really grand ideas of what they want to do with it.
But I mean, I'm sure diagnostics will definitely be part of the revolution, if you will, that AlphaFold is probably causing, like, as we speak.
Yeah, for sure.
Yeah. So earlier you had mentioned like not to go to college if you don't know what you want to do. What would you tell someone who's unsure of what they want to do in their teens?
Gosh, that's hard.
Yeah.
Yeah. I wish I had the magic bullet on that one. So in my interaction with my 17-year-old who has no idea, and it's not uncommon for a 17-year-old to have no idea what they want to do. Why would they? They're 17. It just comes down to, well, first of all, trusting in the Lord, and praying about it and praying for them, and then just walking them through, like, what are your strengths? What are you good at? What do you like? What gives, like, what like gives you energy when you do it? And then finding out what that is, and then pursuing that, and what careers can utilize that.
Yeah.
So
no, that's super important. Like, I don't know, I talk about on this show a lot, like if you're unsure or you're struggling, like looking inward and like asking yourself, what am I pulled towards? What do I like to do? What things invigorate me? It's really the only way, because I feel like anything besides that is just going to lead you down a path that's not going to fulfill you whatsoever.
Yeah, because then it's hard to do the work, right? Like if you're invigorated by something, the work is not as arduous, so like my 17-year-old is like, I mean, he really enjoys people and being around people and social interactions, and while that seems like a typical like teenage thing, he has it to more extreme than like certainly my other two, who are a little bit more antisocial if anything. So so then what does that look like? But then he really enjoys baseball, right? And he's actually quite a good baseball player. So he enjoys science, though he didn't have a great experience in those last semester with a science teacher, right? I mean, so there are these things that you just start to kind of pick out, and you say, okay, what does that look like? I mean, even for myself at 17, I've kind of already described my story. I was an athlete. I really enjoyed athletics. And so then that led me naturally to, okay, well, what can I do to be an athlete or to help athletes?
Yeah.
And that lands me here as a PhD in biochemistry, right? Like I couldn't have seen that one coming.
Yeah.
For sure. So, but pursuing, and I was pursuing something that I enjoyed doing.
Yeah. You just have to kind of follow the leads and, see where they take you almost.
Yeah. And I guess the argument that someone might make, coming back to my comment, don't go to college if you don't know what you want to do. I guess the argument would be, well, you'll find something there. And that's true. It's an expensive way to find it.
Yeah. Right? I think there's much more economical ways.
Yeah, for sure. And that would be my hesitation with it. So,
Yeah, I totally agree. So you go by Captain America.
Yeah.
Where does that come from?
Oh, it comes from just like that idea of my philosophy, right? Engaging students. It started off long ago, actually, introducing myself as, Dr. Sholders or whatever. And then one time I just said, but I encourage my kids to call me the Man of Steel, but you can call me Captain America. And that was right along the lines of like when Marvel was first coming out with like all their like origin stories and those kind of things. And so Captain America's origin story was what had been just developed in the Marvel universe and that kind of stuff. So that's where that comes from, more than anything. And my kids laughed at me whenever I tried to convince them to call me the Man of Steel. That's just a joking, bantering with my kids. So anyway.
Yeah, and just bleeds over.
Yeah, it does. And I think that students responded positively to it.
Oh yeah. I mean, it's so lighthearted, it's so easy to go into a class, especially biochemistry. I think so many people, anything with chemistry in it is just like
it's that last word.
Yeah. But I found it to be a difficult class for sure, but one of my favorites and really engaging, and also one of the more useful ones because it's like the first time that chemistry actually starts to it make an effect, or like you're talking about stuff that actually might have clinical significance.
Yeah, the way I view the reason I like biochemistry is because it actually gave me legitimate answers to the ways things were working at the molecular level. And I was a chemist, actually. I was a chemistry student as an undergraduate.
Oh, okay.
And so then in my taking of biochemistry is because I'd taken like a cell biology class and I'd taken certainly a biology class, like intro biology class and some physiology classes. And those were always like, stopped at a level where I'm like, it seemed like there's a lot of black boxes.
Oh yeah.
Yeah. And so as they delved deeper into biochemistry, I realized, those black boxes are actually not black boxes. There's actual legitimate explanations for why this occurs, right?
Yeah.
Why insulin causes the intake of glucose from your blood. So those are fascinating to me. And certainly in a class like what you took, there's still lots of black boxes for students because to uncover all the black boxes would take way too long to do in a single semester. Yeah.
And it would probably require like a lot more OChem discussions and Gen Chem discussions and like actual mechanisms that we just don't have all the time for.
Right. Exactly. And so that's you're tapping into. There are disciplines that the university is still required for, but I mean, there's still the training takes so long because of the amount of information available and because of the principles that have to be laid under for a student to really understand some of the explanations that will be given at what would be considered more the expert type level of biochemistry and that kind of thing. I mean, honestly, I was trained as a scientist and I was trained to understand biochemistry, but the things I learned in my PhD program were like so narrow because I was in such a narrow field of literature that there are things that as a biochemist, there are entire fields of research that I wouldn't say ignorant to, but certainly I wouldn't consider myself an expert in that particular area. And therefore I view it more from a layman's perspective. Maybe I have the capacity to ask questions that are a little bit more probing because of my experience. But anyway, so coming back to the university, I think there are subjects that are like that. Their university is very helpful.
Yeah. Well, I mean, biochem really, like you said, it pretty much was the key log almost of all of the classes I had taken up to that point, because it at the like perfect junction explained so many things I had learned about. It was like, oh, okay, I see how this comes and this comes and this, like it brought together like over half a dozen classes probably, and like just right there. Yep, it was really cool. And then I took the MCAT. Like half the MCAT seemed like was biochem, so it's really applicable in medicine as well. A lot of clinical applications, and I'm sure drugs that's all biochem, really.
Yeah, I mean, for sure. That's why I enjoy the science, biochemistry, because I think it gives at a fairly fundamental level, it gives answers to why biological organisms do the things that they do, right? And the observations that we make on a more macroscopic scale have the explanations at a microscopic scale.
Yeah, like sure. Mitochondria is the powerhouse of the cell. You hear that like ad nauseum, like from high school bio. Yeah, and then like biochem is where you like actually finally understand what the hell that means. Yeah,
exactly. Exactly.
Yeah.
So yeah, that's why I enjoy it.
So yeah, what do you think like the future of like medicine, like biochem, like research, like looks like in terms of like what kind of breakthroughs?
Oh gosh,
how that'll all look?
I don't know. It's a good question. Because I've stepped out of some of the literature, right? Because I'm more in like education, it's hard to say exactly what are upcoming breakthroughs. I think that though, with the accessibility of, I think AI is going to really help with this. The accessibility of being able to map out genomes, right, and get at data of large sets of data very quickly in terms of personal genomes. I think that probably the bigger breakthroughs are going to be on understanding on a genetic level what's occurring in individual people. Right? And so the hope would be that there would be then a more individualized treatment based off the genetic predispositions of individuals, rather than kind of guessing and doing the guesswork and saying, well, we think it's like this, or we think it's like this, and we think it's like this. So that would be the hope. There's going to have to be, right, I mean, economically, it's going to have to become a lot more feasible to map genomes. Ethically, it's going to have to be, right? I mean,
an ethical nightmare.
There's some real ethical considerations with that. But I think that that's where it's going to go. That, and I think that the editing then of genomes is going to become the next big question.
Like in vitro?
Or even within an individual. So I don't know if you saw this recent report, but there was an individual that a very young, I think is an infant, had to be an infant, that had a mutation in CPS, which is a gene that's central to amino acid metabolism in the urea cycle. Okay. And it's a single point mutation within that gene, but it's deadly. Yeah. I mean, you can be born, but then you're going to either have very serious neurological problems, or you're going to die, or you're going to get a liver transplant. But a liver transplant as an infant is, first of all, availability, right? I mean,
how many infant livers are there?
Right. And then, putting that person through that is terrible, right? So they actually edited in a single individual. They determine what is the genetic mutation that this individual has, and they edited that.
Like globally?
Yeah.
How did they do that?
Well, so I haven't looked at it. I just saw it. Like I only read the news article on it. I haven't had time to go back and look at the actual science behind it. Yeah. But yeah, they edited it, and they're monitoring it. Yeah. Hoping that editing will take over the entire liver.
Jeez. That's...
Yeah.
I didn't think I thought that was like decades, like 100 years down the road.
No, I think we're on the precipice of seeing that. There are some serious ethical...
Oh boy.
Some serious ethical questions that have to be answered, and boundaries that have to be put on it, like legal boundaries that have to be put on it.
Absolutely. So,
yeah. You've probably seen Gattaca. Have you seen Gattaca?
Oh yeah. Gattaca. Great movie.
Yeah,
if anyone hasn't seen it, it's like we're we're there. Like I think we have all of the functional capacity to do Gattaca.
Exactly.
Like I think I heard of a similar thing in China where a doctor, like there were twins and both of the twins had the mutation for AIDS or something. I think it was something like that.
Yeah, you're headed in the right direction, I think.
And went in
more susceptible to HIV or something.
HIV, like that. And then like modified their genome and they came out perfectly fine. He ended up going to prison, I think.
I think he did it at the embryonic level.
Okay.
Which had, I think, which for some he ended up going to prison for some, and so it does puzzle me, like what is the ethical difference there? Because this made the news, it was really positive, lots of people talked about it from a positive standpoint. That was a different thing altogether. In terms of the way it was viewed.
Yeah, it's super interesting though, because I think most people are going to have this sense that, okay, if your kid is born with some sort of severe genetic mutation or defect, if you could go in and give them a shot and boom, it's gone, they're going to live a healthy life. Like, hey, that's pretty awesome. Like that's some futuristic, like really cool stuff. On the flip side, if you give them a shot and make it so that they grow to 6'5" and put on muscle really easily and, NBA kid or whatever, like it's a little different.
Yeah. And I think that, from the standpoint of the science behind it, the treatment of like the one that I was talking about, the CPS gene, or, even like cystic fibrosis or, these types of genetic conditions, these inborn errors that affect a single gene, that's scientifically feasible to fix. Yeah. The idea of like, there are lots of genetic conditions that are multiple gene interactions,
probably across multiple chromosomes too.
That we don't even understand. And that kind of editing, we're a long ways away from that kind of improvement. That you would even see in like Gattaca, where you make someone a better swimmer or something like that. So we're a long ways away from that for sure. I would say, but we seem to be there on some of these diseases that are very rare, like the one I was describing, the CPS gene is very rare. And so pharmaceutical companies never take seriously the ability to fix it because the market's not there. I mean, 1 in a million people have this. That's
no room for profit.
Yeah, they can't. Not only that, but they would go broke trying to do it.
Yeah, right? The R&D would be crazy.
Yeah, so there's just no one that's going to research that. So I think that that could be an interesting avenue that I think does have ethical concerns. But I think those ethical concerns are manageable. In some senses. I mean, if we sequester it off to like purely medical things, I think that would be. And these genetic diseases that have a single, gene.
Yeah. And then of course you get into the like, over medicalization. So like that could get dicey too. Sure. But there's a lot of conversations inevitably that will need to be had about like where would this fit in, what kinds of things are going to be ethical for us to do, and so on and so forth. And it's just going to be one long big conversation, I would imagine, about the ethics of it, at least, because the science and all of that's going to press on, regardless.
Yeah, for sure. So there's a good field for people to go into, bioethics.
But I think bioethics is probably like, if you're going to spend 4 years like learning abstract concepts and books and all that, like, that's probably a pretty important one. And maybe one of the more important ones, actually, come to think of it, because how many people are going to trust ChatGPT to be their bioethicist? Probably none of them.
Sure.
Because we're humans. We want a human to determine the ethics of what humans should do. So that might be
and policymakers, right? I mean, they need like actual information that they can trust. So you need someone that can understand the ethical aspects of it, the biology of it, and then be able to communicate that to policymakers. I mean, that's probably a unique skill set.
It's probably going to be a pretty growing market, I would imagine. That's just probably one of those areas where everyone's super worried about AI and such, like taking jobs. It's going to get rid of a lot of jobs inevitably, but that's just one example of a field that doesn't really exist as much now. I mean, it's a field, but not at the scale that it's going to need to be, because we're going to have so many ethical considerations that like we're going to need a bioethicist for like every doctor probably, or something like that, you know?
Yeah. I mean, so I mean, coming back to your original question, you know, I mean, like, where is medicine going? I can see that being where medicine goes.
Yeah.
I mean, the question with this individual, right, this young kid that was treated in this way is, we don't know what that editor does, right?
Mm-hmm.
I mean, you know, and does it have off-target sites that it edited
mm-hmm.
that will have long-term consequences for this individual? What are those long-term consequences? Right?
Yeah.
So, and we don't know those. None of those questions are answerable.
Yeah.
But in some ways, you know, from an ethical standpoint, and I'm no ethicist,
mm-hmm.
but, you know, if faced with certain death versus this is potentially going to happen, you know, we don't know long term what's going to happen, but
mm-hmm.
we think that this will improve quality of life, improve, you know, is that a reasonable
ask?
Effect? Yeah.
I mean, probably. We already do a lot of things. You know, chemo is brutal. Like chemo, you know, for most people, if chemo was the option to get better for most things, no way. It's terrible. But if it's chemo or certain death, you know, a lot of people are going to choose that.
Yeah, I had a good friend who, you know, went through rounds of chemo, and, you know, I mean, she had breast cancer, and I mean, it tore her body apart,
mm-hmm.
you know, but it was that or say goodbye to your kids and your husband.
Yeah.
That was the option, right? And even then, considering where she was when it first got diagnosed, she was quite young. It was,
mm-hmm.
you know, quite aggressive. She was given still, I think, like a 1 in 4 chance, even with chemo, and she's now in remission. So praise the Lord. But,
that's awesome.
Yeah. But I mean, it was a brutal year for sure.
Yeah.
Not to mention all the surgeries that had to occur. Prior to the chemo. So.
Yeah, but we'll probably have to use that and then other examples in medicine of, you know, how to judge things. And I did take a biomedical ethics course, and there's like justice, autonomy, beneficence, and non-malfeasance for the 4 pillars of it. And I think that these sort of things we're talking about can fit within those bounds, but like we just have to be careful to make sure that it does. Like, if you do a lot of research, research these things in animal models and all of the rest first, and be very, very careful. And also not go, you know, be better about saying what is and what isn't medical. Because like in Gattaca, it seems like it would be pretty easy to dip into the non-medical stuff with genetics.
Yeah, for sure. At some point. The science isn't there yet.
No, not yet.
We can't change traits that, like what you're talking about, more muscle, that kind of thing.
Mm-hmm.
Although I said that, even there is a, gosh, I mean, this is like, there's this image of cattle
mm-hmm.
that I'm trying to remember what gene they changed.
Oh, was it the Tor gene? I want to say it was Tor, because I think I know exactly what you're talking about.
These enormous cattle with these muscles that look so unnatural.
Oh yeah, I mean, well, in like if we want, like, we are probably at the point where if we have, like, you know, fertilized egg, we can probably go in and do that. So, like, you know, we're able to clone and all that stuff. We just don't, which maybe gives us some hope, since we've had this capacity for a couple of years now, and we're not seeing it just fly off the rails. So that's good.
Interesting. So it's interesting. We'll see where it goes. We live in strange times.
Very strange, for sure.
Strange and interesting.
Yeah, but I'm definitely hopeful. I'm trying to stay hopeful. There's a lot of doomer stuff out there.
Oh yeah.
But, you know, keep praying, and that certainly helps.
Yeah, I mean, as a Christian, right? I mean, I can fall back on the hope that I can fall back on the hope that, first of all, there is someone that is still in charge and oversees the whole thing. Mm-hmm. And secondly, there is the understanding that mankind will get themselves, and it has gotten themselves in the past, in a bind that is unsolvable.
Yeah.
That is only really solved by the creator of the world.
Yeah.
That's if I read scripture correctly, that's the projection that scripture gives us.
Yeah.
And not that that's a comfort to me, and it is a comfort to me in the sense that it will come to an end and a just end.
Mm-hmm.
But it's also a warning to me that it will progress to that point.
Yeah, and we'll have to go through some difficult times for sure.
For sure.
Tower of Babel, we're working really hard on building it seems, and that there was a period of time where everyone got scattered and couldn't understand each other, so that might be a future we're headed towards, but on the other side of it,
I mean, if you read scripture in any of the what might be considered end time eschatology passages, there's a fairly significant unifying theme in many of them in terms of the descriptions of the society that faces that, and that is a time of great deception, right? And that's kind of what you were talking about, like earlier with AI, like we're getting to the place where we can't even trust images,
or videos
or audio.
Mm-hmm.
I mean, and some, I can't remember who said this, but I think I was listening to a podcast. There was where they quoted a philosopher saying we live in a post-truth time, right, or a post-epistemological time, right, meaning that how we know that we know something is going away, right, because there's so many ways to fake something, deep fake something, right? So
I like that term though, post-epistemological. It's so true though. Yeah. And again, back to what we were saying earlier, like I think that's why podcasts are taking off, because like certainly some people are probably faking podcasts with deep fakes, but I think that when you have a real podcast with people talking, like it's real, you can see that it's real, it's unfiltered, it's legit, and those sort of things, in-person experiences, like you can't deep fake an in-person experience, at least not at the moment, robots and whatnot, but like at the moment you can't fake an in-person experience, or would be difficult to fake a podcast, maybe not, but I think it will become there. But I mean, physical contact, you can't fake that. We're not going to be able to fake that ever. But so but going back to scripture, a time of great deception, I mean, like we're kind of in that.
We're kind of there, without the advent of AI, I think we were there. But with the advent of AI and humankind's proclivity to sin and use of things in destructive ways. Right? You can't stop it. The genie's out of the bottle.
So where do you think that leads us? Do we have to pass through I have a needle and come out on the other side wounded but still here, or
hard to say. I mean, I would just say this, that societies have gone through the transformations that we have seen our society go through, but they weren't, and what I mean by transformations, negative transformations, right? But they were localized typically to that society, because the ability to transmit the bad ideas and the bad philosophy and the bad theology was so limited.
It wasn't global.
It wasn't global. Like Rome, I mean, ultimately just decayed, right? Morally decayed, but that was all contained within Rome. And as far as the Roman Empire reached, right? But even what was happening in Rome, the outreaches of the Roman Empire was years away from having that, transmitted to them. We're seconds to minutes away, right? So it's global, and so I think that then when you look at scripture, then it describes a summing up of society in a summing up of society in the return of Jesus Christ. Right? So I mean, that's one of the things I say in my class, is that I believe that Jesus is going to come again, and he's going to set things right.
So maybe that's soon.
I think it is soon. I mean, every generation of the church has been saying that. Peter right? In 2 Peter 3 says,
Yeah.
he talks about the end times, and that there will be mockers who will say, you've been saying this, that it's going to come forever and ever. And, and he addresses that issue. And that was 2,000 years ago that people were saying, oh, you've been saying that forever. And we have been saying that forever.
Yeah.
And we've been, not forever, but we've been saying it for a long time.
Mm-hmm.
But I think that there are indicators in our society that, and from a prophetic standpoint and from a theological standpoint, that put us at the precipice of our Creator stepping in and saying, "That's enough."
Yeah,
that's enough.
Can't say I disagree. It's although the issues might be of a similar quality, the degree and kind and scale and speed at which the things can happen is totally different.
Yep.
So
yeah, and we're getting to the place where that's the best way to put it: the speed, the scale.
Mm-hmm.
Yeah, I mean the issues, humans' proclivity to sin and to be in rebellion against their Creator is always present.
Yeah, and
has always been present. But the scale at which that's gone and the rapidity of which it can go out, in the philosophies that people are gravitating to on a global scale, I think puts us in a place where, yes, that our Creator is going to step in and say that's enough.
Yeah, Sodom and Gomorrah was 2 cities, but the whole world seems to be Sodom and Gomorrah at this point.
Absolutely.
Yeah,
absolutely. And
not all of it, but in a lot of ways.
Yeah, we don't know what the philosophies of Sodom and Gomorrah were and what they had embraced.
Mm-hmm.
We could only really see the behaviors of Sodom and Gomorrah, but they had certainly embraced, and or the events that precipitated the flood. When you start to look at that scripture, there was these small, what I would call small scale illustrations of what might be called the day of the Lord,
mm-hmm.
right? And the day of the Lord being this in time eschatological event. I have a hard time saying that word.
Yeah,
where He steps in and brings a final judgment upon humanity and sets up a time in which humans will be submitted to Him fully, to His Son fully, Jesus Christ.
Yeah.
So
that's awesome.
So I'm looking forward to that.
Yeah. So what's next for you? What are your plans for, the upcoming years and teaching and more research? What do you got going on?
Yeah. So I'm working on a 3rd edition of the book that you worked on. So I'm working on that this summer. Next summer, I'll probably work more on that. So I think that I've actually, before we started, you asked the question if you had a lot of interviews, and no, I haven't had a lot, but I've had a lot of people ask me to do interviews.
Mm-hmm.
And I'm wondering if there is, as I'm doing these and I'm talking to students, if there's, at least with my students in in the classes that I teach, if there's an audience that would be interested in some of my, my views on science and my views on how they interact with theology.
Yeah.
Certainly I think that, and so I've wondered, like, should I make YouTube content or something like that?
Yeah.
And so I'm praying about that. I know that there are some students that have that because they come and ask me. I just don't know how widespread it is. I know that there are some students that have no interest in that as well because they've indicated that they're
on Rate My Professor. Yeah, you either have glowing 5-star reviews,
right.
Best teacher I've had, or he said he was Christian, 1 star. Yeah,
exactly. So I know, but and this, I don't teach that stuff in class. I introduce myself as that, but I think that there are. So I just wonder if that's part of where I should go.
Yeah,
is the most often asked question I get from believers and non-believers alike, if they want to have a discussion besides straight biochemistry.
Yeah. Hold on 1 sec. The memory card.
Oh.
So wanting to maybe branch out. I think it would be, there's definitely an audience for it, for the return to Christianity and these more traditional beliefs, and seeing how we can blend it with modern society.
Yeah. I mean, the most often asked question I get from students, besides just content on biochemistry and, how do I do well in this test,
mm-hmm.
Would be, how do you reconcile your faith with science?
Yeah. Yeah. What would be like your elevator pitch for that? Because I know that a lot of people hear science and religion, they're like, they can't go together. Like,
I don't see a conflict.
Yeah.
Between either one of them. I see in the field of biochemistry itself, I see complements to my belief that there is a creator,
mm-hmm.
and evidence that there is a creator.
Yeah.
And so like my elevator pitch would be this, that you have two different realms of knowledge and two different sets of data,
mm-hmm.
right? You have scientific data and you have what we would consider biblical natural law data,
mm-hmm.
right? Special revelation data, general revelation data,
mm-hmm.
right? And I think that we don't have all the data on each end of it.
Yeah.
And even if we did have all the data, certainly in the science we don't have all the data, but I don't think we have the correct interpretation of all the data, certainly either.
Mm-hmm.
And so my answer would be this: when all the data is present and the correct interpretation of the data in each realms is present, then we'll find perfect consistency between the two of them.
Yeah.
I think the idea that there is a conflict between them two is a philosophical statement.
Yeah.
Based off of a philosophical worldview rather than a statement of truth.
I agree. Yeah. And we've talked about this before, but science like hinges on philosophical contingencies,
for sure.
Know, whether or not you need like unprovable ones. Like, it is good to research this thing. Well, what is good and bad? That's a philosophical claim that you can't prove with
right.
the scientific method. It's a very, metaphysical claim.
Right.
So
yeah, the statement science is the only avenue to truth is not a scientific statement.
Exactly. Yeah. Right. Exactly. So you need some sort of metaphysic and way to think about it that's not provable by science. So
yep.
Yeah.
So
yeah, Dr. Sholders, it has been a pleasure having you on the podcast. It's always great to talk to you. So.
Yeah, it was great doing it. I enjoyed it.
Yeah, good. So, thank you.
Absolutely.
Awesome.